Greetings and salutations. Welcome back to part 4 of my piston assembly tutorial. Today I'm going to be talking all about joints.
A bag of weed, everything is better with a bag of weed. No, you don't need nothing, you don't need speed, because everything is better with a bag of weed.
No, you Gumby, not that kind of joints. Motion joints. Infusion. So yeah, today I'll be modelling just a few more quick little bits to add into the assembly, and you'll see why. And yeah, let's get pumping. I'm Garth, and this is welbot 3D Prints. Okay, so picking up where we left off last time, we've got our crankshaft here, and we've got our other components, the piston and the arm, and we're going to create the assembly. And to do that, we don't really need to, but just for the sake of clarity, I'm going to create a couple of extra components, one of which will be a pin to go through the center of this, because there would be one, and the other will be a shaft for the head to actually slide through. But to start this pin off, we'll go new component, because it is going to be its own component, and we'll call it pin, and we'll create a new sketch on that plane, and then we can come in and project the curves of the hole, hit OK, stop sketch, and you can see that the profile has been created in the center of the head. So we select it and press E for extrude, and if we look at our sketch, you can see the diameter of the inner cylinder, as it were, is 76.6, and that kind of lines up with the edge of the cut out there, so I think we'll just use that as the dimension. So since it's in the center, we'll do symmetric, and the distance we want it to go is 76.6 divided by 2, and we do want it to be a new body, and there we go. That's our central little pin. So now we'll unhide the arm, and to make things a little bit neater, we'll just drag these away from each other so we can see them clearly. And to make things a little bit neater for later on, because these three parts are going to be basically linked to each other, and we do need to make copies of them, because there's going to be 4 of them. What I'll do is make the pin and the piston subcomponents of the arm, and to do that, all we need to do is drag our little pin up to the arm. When it highlights grey, drop it in. It'll ask us if we want to capture the position, because we've moved it, and just say yes, capture position, and we'll do the same for the head. And as you can see, we've now got the head and pin each as their own component, but as a subcomponent of the arm itself. And you can tell that because the icon has changed to like a multi-box icon rather than the single cube kind of icon that is on the pin and head itself. But as you can see, all the sketches and everything moved with those. so they're still nice and clean, and it just makes it a little bit easier because that way when it comes to copying, like if we select the crank, select the arm, you can see it selects all three pieces rather than having to go through and select each piece. Okay, so now we've got it set up as subcomponents. What we want to do now is create the actual joints between the different components, and it's probably better to start this by joining the arm to the crankshaft. And one thing to note about creating assemblies is you need to have a grounded part. I'll explain a little bit about that later. So we've unhid our crankshaft, and just to make things a little bit easier, we'll pull those out of the way, because what we want to do now is, I might even set the, actually we can probably go with the main one. Select the main thing as the active component, and now if we come up to assembly and go to joint, we'll capture position, because it's asking us if we want to capture position because we moved those objects from where they were. And when you're creating joints, you'll get a list of component 1 and component 2, and what you want to do is select the component that you want to move to another object as the first object. So if I selected the crankshaft as the first object, it would move to wherever I told it to link to in component 2. I'm happy with where the crankshaft is at the moment, so I'm going to select the arm as the first component, and because I actually want to select the midpoint of this hole, you can see when I hover over this hole there's a little circle in the center, and you can see when I move my mouse it's going to disappear, but you can see the little white dot here and here as I hover over. Now the furthest point away is the center point on the opposite side, and the next one closest to it is the center point basically of the cylinder, and that's what we want. Now, as I said, when I move the mouse it disappears, so if we hold Control, or I think it's Command on Mac, it allows me to then select that center point. And what we want to do is make that center point line up with the center point of this cylinder, and you can see that because there's a face there, it actually does show me the center point. If for some reason it won't show you a center point, you can actually, before you select the component, if you right click you can say between two faces, and it'll actually let you select two faces and allow you to select a midpoint between those two faces. But because we've actually got a midpoint here that we can select, we select it and you can see it moves into place. So that's shifted over, but as you saw when it moved, it shaked a little bit. So if we hit animate, it'll shake. That little animation there indicates it's a rigid joint, which means it won't move. They're locked tight together as though they were glued. And what we actually want to set for this is a revolute joint, because the arm should be able to rotate around that cylinder freely. And you can select the axis. So if, for instance, it was rotating around in the wrong direction, so if we select X, it basically just allows you to select exactly where you want it to go, or you can select a custom one, but we do want it to rotate around the Z axis as it's indicated, so that's fine. Right, so we've got our piston arm in place. Now there's a couple of different ways we could do this. With the pin and the piston itself, I might actually link those two before I link it to there, just to show something else. So if we go assemble joint, and we'll move the pin inside the piston itself, and as you can see this time it won't allow us to select the center point of the cylinder, so we'll have to do between two faces and select that face and that face, and now you can see it brings up a construction plane there. Now because we did select between two faces, we don't actually have to hold control to select that center face, or the center point rather, because what you'll find is, because this isn't a hole, if we hold control and then try to select it, it actually shifts the point to the outside. And it's doing that because there is actually a surface underneath the mouse. So holding down control is really only if you're trying to select a point that exists in vacant space. Because we've already selected between two faces, if we just select the end of it, you can see that it selects that central point right in the middle. So now for component 2, again, probably find we can't select the central point, and if we try and select it from here, it doesn't actually give us a central point right in the center between here. So again, we'll do between two faces, and we'll select that face and that face, and then if we click there, you can see that that's shifted that into position. Now, while that is technically a revolute joint, we don't necessarily have to have it as a revolute joint, because the pin is going to be rotating around within here to save on computation and so forth. We can just set that as a rigid joint. And you can see that indicated by that little marker there. And now what we'll do is do another joint, assemble joint, and I don't think it's us select that midpoint. No. So again, we'll go between two faces. And you don't actually have to do between two faces either. You can actually just select, say, that outside face and then that edge of the hole, and it will move it into position, but then you'll have to kind of manually position it within there so that it's centered. So just doing it this way makes it a little bit easier by automatically centering it for us. So saves us a little bit of hassle. So for the second component, this time, because it is a hole, we can see that there's a central point within that hole. So if we hold down Control, that allows us to select that central point. We do want that to be a revolute. Oh, there we go, so it automatically updated it. So that's those three set into position, and they've got their correct joint types for what they are. So now we need to basically make the other three arms. So if we highlight that and press M on the keyboard, it'll bring up our move copy box, and we do want to basically do the entire component, which contains the subcomponents, and we want to create a copy. And if we just go to our right view, we can shift it across to that one, and we hit OK. Now, as you can see, it did keep the joint up here, but it didn't keep the joint down there in the center. As you can see, that it's a bit hard to see, but there's a little flag in the middle there. That basically indicates it's a revolute joint, and the direction of that little flag indicates that it by default rotates that way. You can play around with it, so like if I created it from that side or something, you might find the flag faces the other way, but basically just indicates that that's a revolute joint in that direction. So you can see there's a little flag in there, so because there is a revolute joint between the pin and the arm itself, but you can also see the rigid joint. So we'll have to create the bottom joint again, but this time we'll do it a little bit differently. But before we do that, we'll create the other two. So select our original one again, M for move copy, create copy, and we'll just pull that across there and pull that down so that it's in line, which it doesn't want to quite line up. Still not quite there. So if we zoom in a little bit more, it gives us finer adjustments, so that'll do there. That looks pretty good. So now that we've got this one in position, rather than having to do a move across and down again, we can just select that new component and M for move copy, create copy, and we just drag it across and OK. So we've got our 4 pistons in place, except that they don't have their joints down the bottom for these ones. So we'll go assemble joint. Actually, assemble and go as built joint. And this allows us to select 2 components. So we select our arm and then the crankshaft, and because we need to select a position, take a side view here. That appears to be the center of that circle. So we can click that, and as you can see, it revolves around. Oops. So basically do the same again. As built joint. This time we select that arm and our crankshaft and select that one. That is correct. And one more time. As built joint, arm, crankshaft, and a little point. Okay. So now we've got all of those linked together in that way. And I might actually create one more piece, which I might ground as well. You can actually select multiple grounded parts, but kind of makes sense to have a grounded part for this to revolve around, because this would obviously normally be inside the engine block. Given the design of that, it would obviously be bolted onto something that spins, and this one would just insert into a hole. So that's probably the best way for us to do it. So we'll just make a new component, and we'll just call this stand. That'll do. Not going to be anything complex, it's just going to be something as a kind of reference. And probably might be easy if we just go create sketch. We'll just do it on the end of that face. And it has already created that profile, but I don't think it'll have any edges, so we'll go project include. I'll just say project. Hit OK on that. And if we select that and we hit O for offset, that'll allow us to drag out a little box, and we'll just drag it out 10 mil. That'll be enough. And maybe to demonstrate another little sketching tip, as it were. I'll just hide, where's the crankshaft? I might as well hide all of those as well. So just make it easier to see. So if we select our line, I'm basically just going to create like an A-frame. But there's some trickery you can do with the line command. If you hover over a line that already exists, you can see that there's a little blue X there indicating that it'll join onto that line. And because this is a circle, quite often you'll want to draw a line at a tangent to a circle. And if you don't necessarily have any specific requirements about where that tangent's going to be, you just know that you want the line to be tangent. If you hold down the left mouse button as you draw that line, you can see that as I drag it around, it actually maintains tangency. And you can see there automatically created the little tangent constraint icon there as well. But sometimes you might want to create a line perpendicular to the circle itself. And as you can see, if I wanted a line to go perpendicular out this way, you can see that it's not quite working because it's automatically created that tangency one. I'll just hit escape and delete that one. Trick is, if you go to the top or the side or the bottom and click and drag, it creates a perpendicular line that you can then drag around, and when you finish creating it, it's automatically perpendicular without you having to then go and set a constraint, which is very, very handy. But for this particular instance, might as well just do the tangent again and drag it out to there and just drag it across there. So stop sketch. Actually, I'll just undo that. Make things a touch neater, we'll trim that inside circle off. So now we'll unhide our other parts. Oops. And as you can see, we've got that positioned just on the end there. So I want to select that profile, E for extrude, and we'll just drag it out that far. Obviously not really important how far it's going to go because it doesn't really matter. But that basically just gives us something for us to create a joint around for this, and we can use this as our ground as well. So if we right click on that component and select ground, that basically tells Fusion that is a completely static part, and anything that we join to it will move relative to that. And that's basically what you need for any kind of assembly. You have to have a grounded part of some sort, or you don't have to, but if you don't have a grounded part, as you can see when I move this, it moves all of those components together. Whereas if I now go assemble, join, select that and select that, now you can see that that rotates, which is what we want. So we hit OK on that. Now if we move it, you can see that it actually revolves around that part rather than shifting all of those parts. So next thing I will create another new component. Set that as the active one for a sec. So a new component, and just call this block shaft. I'm not going to go ahead and create an entire engine block or anything because that's just a little bit too much. I'll create an offset plane. We'll just use one of those faces. So we've got a construction plane there. We'll create a sketch on that. And I'm just going to project the top circles of, actually I only really need to do one, come to think of it. I'll cancel that. Undo. Oh, there you go. So we've got our little circle there, but because I actually want to kind of work with that, if I select that projection icon, which kind of looks like a constraint icon, press delete, you'll see that it's turned it into a proper sketch line rather than a projected sketch line. And that can be handy in certain situations because projected lines don't always let you do everything you'd want them to. So if you ever project a sketch and find that you're unable to trim part of it or do something in particular with it, you can delete that projection and it'll just turn it into a proper solid construction line. So what I want to do here is create an offset, and we'll make it about 20 mil. Yeah, that looks pretty good. So now if I select those two circles, we come up to our sketch panel and go rectangular pattern. This will allow us to pattern these circles either this way or this way. Now I know that I want it to go this way, but we want 4 of them, so we can see that the distance has been altered here, whereas this one's 0. So we'll change that to 4, and there's 4 circles there. Now we can continue to drag that out until they're in position, nicely centered. Hit OK, and there's our little profiles. So just to clean things up a little bit, get our trim tool, get rid of these overlapping edges, and then we can stop sketch, and if we select that little profile and hit E for extrude, I might just go to the side view, drag that down, that should be good enough. We do want it to be a new body, so there's our little shafts in which the cylinders will slide, and kind of hides everything. So what I might do is actually cut it in half just for the purposes of this demonstration. So if we go modify, split body, select that as our body, and the splitting tool, because it's on the center axis, we can just use that. Goes right down the middle, hit OK, and now we've got our 2 halves. So if we look in here under bodies, we see we've got 1 half and the other half. So we'll just hide that one for the moment, we don't really need it. So because these shafts aren't going to move, we can ground them. Actually, if we go back to our main component, you can see that icon there indicating that we've grounded it, and we just want to make a couple more joints, and the components that we want to join are the head, and we actually want that to slide up the center of this. So if you hover over that top face and hold control, It'll allow you to select that central face. We want that flipped, but we don't want it as a revolve, we want it as a slider. So hit OK on that, and basically just repeat that process. So we want that, and that, and again joint that one, and since it's up there we'll just make sure we're selecting the right thing. Flip that. It is a slider. It is sliding on the correct axis. Okay. And one last one. Joint. Select that. It's giving us a central point, so we can just select that. Sliding joint. Okay. Right. So as you can see, now when we rotate that around, we've got the motion that we would expect to see. Now there's a little bit more that we could go into, but I think I'll probably save a bit of it for another video, but we'll just gloss over it. If we go up to joints here and turn the light bulb on so it shows our joints, you can see these markers indicating the kind of joint that it is. If you mouse over these joints, there's a little orange thing here at the end saying edit joint limits, so you can kind of define minimum maximum values. So if you had something that revolves around a central point but you only want it to move in an arc of 30 degrees, you could limit it so that it can only move between those degree points. As I said, I'm not really going to go into that today. The one thing that you might sort of expect, given that there's an animation workspace, is that you would be able to come in here and animate that, but the animation workspace itself doesn't actually honor the joint constraints. This at the moment is basically for creating explosions, which it might kind of, no, it doesn't have one set up. You can, I think, right click and say auto explode, and basically it'll just move all of the parts away from each other to show you the individual components, and then you can animate those components sort of coming together. If you wanted to demonstrate to somebody how to construct a multi-parted object, you can also do a manual explode, and what that will allow you to do is basically manually move the parts wherever you want them to go, and if you wanted them to go in a particular order, for instance, you can have one part move and then another part and then another part and so forth. Whereas if you do an automatic explode, all of the parts will just explode apart from each other at exactly the same time. So that's one thing you do need to be aware of. You can't actually animate those joints in there. What you can do if you do want to animate is if you come to the Assemble menu and go to Motion Study, you can actually use this to create an animation which you can then render out in the rendering workspace. But I think from memory you have to actually render at least one frame first, and then it should give you an option to render out a motion study. But again, this can get fairly complex, so I'm not going to go terribly far into it today, but just to give you an example, if I select give the selected joint, select that little joint there, so you can see it popped up down here, that's the joint we're going to animate, and as you can see this red line popped up down here, and basically this red line is the timeline. So we're starting at 0 here, and then we move across to 10 and or 20, sorry, 40, 60. So that's your timeline for the animation. So if we right click on 20, get this little yellow point that shows up, and that's essentially a keyframe, and then you can set the angle that you wanted it to move to, because this is a revolving joint. If we set it at 180, you see that it did actually rotate that at 180 degrees, and it also had an adverse effect of flipping those over, which is why I said I'll get into it another day, because there's little tricks that you can do. But if you slide that back and forwards, you can see that it basically rotates that shaft 180 degrees, and it does honor those joint links. And then say we wanted it to rotate the next 180 degrees, come across to 40, and we'll just type 360, and now you can see it does a full revolution. So yeah, had they all been facing the right way, you can actually click on this little button down the bottom here, which essentially just tells it to play in a loop. So if you hit play, it'll just play that over and over again. Or if you set that one, it'll play it forwards and then backwards. So depending on the kind of animation that you want, you can do it that way. Or alternatively, you can actually animate each joint separately. So if I come back to point 20 and say I wanted to animate that particular joint there, you can see it creates another line, and that line basically indicates the timeline for that second joint, which we can see over here. So if you had several different joints that weren't necessarily linked, so if you had like an object with two arms coming out either side of it, you might want to animate one arm and the other arm, That's basically how you would set it up. Because the joints in this particular thing are all linked together, there's no real need to do that. But yeah, that's just to give you an idea of how you would do that should you want to. But essentially, if you want to see the animation, you can just hold the left mouse button down. Oops, not for that long. Hold the mouse button down on the part that controls the motion and just drag it around, and that's how you get that to work within the workspace. So yeah, that's about it. Alright, well that pretty much wraps it up for this tutorial. If you've got any suggestions or questions, maybe ideas for tutorials you'd like to see in the future, feel free to leave them in the comments below. And if you like what I do and want to support me, because Lord knows I could use some help, there's a couple of links down below where you can donate, and don't forget to like, subscribe and all that kind of jazz. And till next time, catch you later. Bye.